Good evening, I'm Dimitri Bellini, CEO of Quadrata, premium partner for Zabbix here in Italy, and thank you to stay here to the Zabbix Summit 2021. And today we want to share with you our experience with Postgres in high availability. And we start from the question coming from our customer. Is my zabbixsdb architecture highly available? Does it solve my Zabbix slowness during housekeeping? Does it save my precious NVMe space? And what about backup and disaster recovery? And this is the last question is very important in most of our cases. But we start from here. After some times to find the best DB solution, this journey was started 2 years ago, or maybe 3 years ago probably. And after testing and poking around, we decided to go with this software: Postgres, etcd, Patroni, TimescaleDB, and pgBackRest. But before we start with our architecture, we want to share also this slide that explain, or maybe that show the ranking of the most important database solution that are already running in IT infrastructure. The most used seems Oracle and MySQL, but as you can see, Postgres is growing every year or maybe every month. So we also notice in Italy that most of our customers are trying to switch from Oracle workload to Postgres because it's a very robust solution and seems to have all the features that Oracle need. This is a complex schema. We try to represent a classic scenario of installation of Zabbix in high availability, and the database is still in high availability. And we start to discuss about timescale. Why? Because timescale is an extension of Postgres that can provide a lot of benefits inside our Postgres installation. You can use in standalone, in classic standalone Postgres installation, but we also use in high availability architecture because provide a very easy way to solve the issue of the housekeeping process. So it's very easy to drop partitioning because it's something directly in the code of TimescaleDB. TimescaleDB was born for time series data and have a lot of feature around this kind of data. But in our case, in Zabbix case, the most important thing is how Timescale manage automatically the creation of the table partitioning. And this information is provided from the Zabbix server since Zabbix 5.0, and also we have the compression of all historical data coming from Zabbix. And this is a very good solution and have a good ratio, compression ratio. Pro, as I said, it's very easy to implement, very easy to manage. The cons is that we must define a global rotation for the items. So you cannot use anymore the specific retention of an item, but you must define a global one. And in most of the case, I think is the best solution. Big company is the best solution. Have a single global definition of the retention. And how we manage the cluster, the Postgres cluster? We use Patroni. Patroni is the software that can manage, maintain, and monitoring the high availability of the Postgres nodes. So it is very important piece of our infrastructure. It's also the software that create the replication and try to manage all the information when there is a fault in a node. It seems like a core sync peacemaker, no way to work, but more simple in such a way. Another very cool feature of Patroni is that you can create a simple YAML file to define all the information for your specific high availability cluster, DB cluster. So you don't need to poke around in multiple configuration file, but you only need to provide a single YAML file. So it's very convenient, very easy solution. But Patroni must require a sort of bus to share information through the DB cluster, no? And there is multiple choice, but we start using some times ago we start to using etcd because seems more simple and more reliable for us, and you need to keep in mind that you need at least 3 nodes to reach a consistency for etcd cluster. etcd is based on the algorithm Raft, and the Raft have a single cons, is very sensible to the performance of the node. So latency, network latency, and I/O latency of your system. So you must pay attention on the hardware of the single nodes, because if you don't have a good hardware, you can have a problem of the stability of the etcd cluster itself. So look and try yourself in your installation, but usually in our production environment, also using VMs, the cluster, it's good enough, okay, for production environment. So maybe Patroni also provide some other way, to solve this kind of distribution of information. But at the moment, seems the etc seems the most stable. Okay, they have also implement some other internal Raft algorithm, but I still not tested, and I cannot say it's good at the moment. But maybe you can try. We need another piece of software, the balancer. Why? Because in our architecture we have a classic architecture of master and slave DB instance. So we need to understand who is the master, and Patroni is able to provide, or maybe expose, an endpoint, and using this endpoint, and for instance using HA proxy or other hardware proxy, for example F5, we can health check the endpoint exposed by Patroni for the HTTP request, HTTP response equal to 200. And in that way, we can understand who is the master node in our cluster. It's very easy setup. Our Zabbix server must be configured with the IP address and the port coming from the front end of the HA proxy. And the HA proxy will revert the connection to the master node based on the health check made by itself. And now we have to discuss about Replica. Replica is coming from Postgres, but is managed by Patroni. Replica in Postgres is made using a concept of write ahead log. It's a sort of a transaction log that will be transferred to the replication node. In generally, we use the default replication mode that in Patroni is the asynchronous way, and in our case I think is the best one because do not require so huge hardware. Okay, so I think if you use the default one, it's okay. And now we have to discuss about backup, because backup is not a replica, no? And replica is not a backup. Replica don't cover all kind of possible disaster inside your database. And you need a solid solution for backup your data and export your data in a safe place. And we decide to go with pgBackRest. pgBackRest because it's very easy, is a single binary, is a full feature software that cover backup, incremental, differential, and point in time restore. Have a lot of feature, many, but generally speaking, you can stay very close to the minimum one. But keep in mind that you can, as a pro, you can manage to store the database backup in multiple storage solutions like file system, CIFS, NFS, S3, Azure, Blob storage, and Google storage solution. So in our case, we prefer to go with S3 or maybe compatible S3 solution because is more efficient and provide more trouble-free solution. Another good point is that you can use pgBackRest for classic backup, but also for disaster recovery scenario. Okay, I don't see at the moment cons, so I would suggest pgBackRest as a backup solution for your Postgres architecture. And what about Kubernetes? No, Kubernetes is a new buzzword, maybe a new, very nice new architecture. We start to play with Kubernetes since 2 years ago, and in the last few months we have to understand if we can start to move some workload, some Postgres workload inside the Kubernetes. And to do that, we understood that we need an operator. An operator is a sort of an automation inside Kubernetes to deploy and manage a Postgres cluster, or maybe multiple Postgres cluster. We start using the Patroni implementation of the operator, but during our journey we discover a lot of problems related to the documentation, very poor documentation. And in most of the features are very specific to Amazon AWS. So for our test environment that we use on-premise or open source solution for our Kubernetes, it was not so easy to achieve a good production environment. And we decided to go to find another operator. And we found Crunchy Data, Postgres operator, and we see a very good product, very well documented, with the last version V5 have all the features that we need. So backup, high availability, directly exposed from the operator, declarative Postgres definition. So it's very, very convenient to have a declarative Postgres definition for your instance. And there is open source license and an officially supported version like Zabbix, no? For instance. Why is important? Because if you must go in production with a cluster, a database cluster, you must have someone that can help you in case of problem. So I would suggest Crunchy for that. And the operator is provide an integration for pgBackRest backup. So when you define your Postgres cluster inside the operator, everything is managed, so backup, high availability, the Patroni, and much more is already coming from the Postgres operator. And it's very, very easy to create this kind of configuration. Very, very impressive. And for today, it's all. And thank you to listen our presentation. And maybe if you have a question, we are in our virtual booth to answer to questions related to Postgres and many, many others. Thank you to stay with us.
Thank you, Dimitri. This has actually been one of the use cases that maybe hasn't been covered as much as we'd like to, so you're kind of filling a niche here. And of course, we do have a few questions about this. So first off, what should users avoid when configuring streaming replication? Any potential misconfigurations which could cause failure of the replication?
Thank you for your question. And this is why we decided to go with Patroni, because you can create a mess with multiple configuration files like Postgres and high availability tools and so on. So in Patroni we have a single file, and most of the configuration is managed directly with Patroni, and we don't see any kind of problems with replication and other configuration parameter. So thank you.
Next up, so a concern about the networking. Could a slow network between the two database nodes hinder the replication process, especially maybe with large transaction numbers? So if you have large instances, large databases, what would be the network requirements or maybe necessary tests to perform beforehand?
Good question. We don't see at the moment any kind of performance related to the network throughput. As I can see, we have a multiple customer with Patroni, and Patroni runs on VMs, and the real concern is related to the VMs itself, because the VMs share a lot of resources with other VMs inside the same hypervisor, and in some cases we saw a degraded performance during the backup of the VMs, and you may put some more attention on that side compared to the Patron itself.
And one more question about not necessarily Patroni, but comparing Patroni to different solutions. So what about Patroni versus the PAF, pacemaker agents? Any pros, cons to using Patroni versus PAF, of course, if you do have experience with it?
We don't play so much with PAF, but we know pacemaker core sync, and we use every day for Zabbix server services, and we know that there are some constraints related to the multicast layer 2 network and other requirement. So when we try to use, when we discover Patroni, we see that there is not only a classic way to resolve the high availability problems of Postgres, but something new that is able to deploy a Postgres cluster, and we only need to use a single file configuration. So it's very convenient, and we also are able to bring this knowledge in Kubernetes, because most of the operators are using Patroni inside the architecture. So I think you must try Patroni.
Thank you for answering our questions, Dimitri. And if you have more questions, feel free to use the chat, or you can visit the Quadrata sponsor room and ask more questions about this particular use case, or maybe just ask about other use cases that Quadrata has had experience with. Thank you.